Hello everyone, good morning and namaste. It's me Arjun Pokhrel, science teacher of Sagarmatha Secondary School. Dear students, welcome to you all in my online class. Today I am here with another session of the online class of class 8 science, and the name of the chapter is pressure. Okay, dear students, how are you? I hope you all are fine, you all are healthy, and you all are staying at your home, and you all are watching my class regularly. Dear students, today once again I am here to express some of the ideas and to facilitate you in the online class of science subject. Dear students, without further delay, let's begin today's class. In the previous class, we had discussed about the liquid pressure, and we had proved one formula, that is liquid pressure P is equal to SdG. Okay, we have proved one formula, that is liquid pressure P is equal to SdG. That is liquid pressure is directly proportional to height of the liquid column, and liquid pressure is directly proportional to the density of the liquid which is kept in the container, and liquid pressure is also directly proportional to acceleration due to gravity. Liquid pressure also depends on acceleration due to gravity. Okay, these three things, S, D and G. Here I'm going to discuss about the consequences of the liquid pressure. First of all, the pressure exerted by liquid increases with depth. Okay, we have proved the liquid pressure P is equal to SdG, that is liquid pressure is directly proportional to the height or the depth of the liquid column. Okay, height or the depth of the liquid column. For this, here you can see one activity. This is the can or the bottle or any container, okay, which is filled by liquid, and here you can see three holes, A hole, B hole and C hole. Okay, three holes which are placed at the different height of the container. Okay, three holes are made at the different height of the container, and the container is filled by the liquid, and these all holes are opened at once. Okay, then after these all holes are opened at once, and then after, and here you can observe, here you can see the speed of the liquid which is coming from the hole C. Okay, is more than the speed of the liquid which is coming from the B, and which is coming from the C. Okay, it is because liquid pressure is directly proportional to height of liquid column. जस्तो तपाईहरुलाई जस्तो यस्तो एउटा मिनरल वाटरको बोतल अथवा कुनै कोल्ड ड्रिंक्सको बोतलहरु तपाईको घरमा पनि छ होला। सबभन्दा पहिला के गर्नुस्, यो जस्तै कोल्ड ड्रिंक्सको बोतल छ भने यसको तीनवटा लेभलमा हाइटमा कोलहरु बनाउनुस्। ओके, मेक थ्री होल्स एट थ्री डिफरेंट हाइट, थ्री साइडमा हैन, फेरि तलमाथि हुने गरी तीनवटा होलहरुको होल बनाउनुस् सबैभन्दा पहिला मुख्य कुरा। त्यसपछि त्यो होल बनाइसकेपछि त्यो होललाई बाहिरबाट टेप लगाउनुस्, त्यो होललाई पुरै टाल्दिनुस् एकछिनको लागि। त्यो होल हामी टाल्दियौं र यो बिकरमा हामी यो जुन कोल्ड ड्रिंक्सको यो भाँडो छ यसमा पानीले कम्प्लिटली फिल गरौँ, र त्यसपछि त्यो जुन तपाईहरुले टेप लगाउनु भएको थियो त्यो टेपलाई एकैचोटी खोल्दिनुस्। जस्तै मिनरल वाटरमा पनि तपाई घरमा गर्न सक्नुहुन्छ। त्यो टेपहरु एकैचोटी खोल्दिनुस् र जुन यो तीनवटा जुन होलबाट जुन धारा निक्लिन्छ त्यो धारामा सबैभन्दा कुन धारा अलि टाढासम्म जान सक्छ, ओके, त्यो कुरा तपाई विचार गर्नुस्। तीनवटा डेप्थमा, तीनवटा हाइटमा भएको धारा मध्ये सबैभन्दा धेरै स्पिडमा सबैभन्दा तलको धाराबाट पानी आउँछ। किन भन्दा हामीलाई थाहा छ लिक्विड प्रेसर इज डाइरेक्टली प्रोपोर्शनल टु हाइट अफ द लिक्विड कलम। As the height increases, then after liquid pressure also increases. Okay, you also can do this experiment at your home. तपाईं आफ्नो घरमा पनि यो एक्सपेरिमेन्ट गर्न सक्नुहुन्छ। Okay, here take a can with side holes A, B and C at a different height as shown in the figure, and fill with it with water. Okay, and make sure that all these side holes are kept closed. सबभन्दा पहिला सबैले के गर्ने, closed, make sure. Okay, and now open all these holes A, B and C simultaneously at once. Okay, and then the speed with which water spouts hole out is the greatest for the lowest hole, okay, through the side hole C. Okay, this shows that pressure increases with depth. Okay, and this principle is also used in the construction of the dams. Okay, construction while making dams. Okay, the bottom of the dam is made wider because there is more pressure at the bottom of the dam. Okay, and to withstand such a high pressure, the bottom of the dam is made wider so that they can withstand greater pressure due to water flowing in the dams and water canals. Similarly, a bucket can be filled faster at the bottom floor than at the top floor of a building. Okay, a bucket can be filled faster at the bottom floor than at the top floor of a building. Okay, for example, in your home, there may be the water tank at the top floor. Okay, and there may be presence of tap at the first floor, second floor, third floor, and open all the tap at once. Okay, and you can observe that the speed of the water flowing that is more at the tap which is present at the bottom floor in comparison to the second and the third floor. It is also due to the what? It is also due to liquid pressure. Okay, and in our body the blood pressure is more at the feet than at the brain. Okay, in case of our body, the pressure of the blood in the feet is more in comparison to the brain. It is because of the height of the blood column or the liquid column at the bottom of the feet is more in comparison to the brain. Same reason. Okay, so the liquid pressure is directly proportional to the height of the liquid column. Okay, now another activity. Here you can see a liquid find its own level. Okay, liquid find its own level and it does not depend on the shape of the container. Okay, pour water into the container tubes as shown in the figure and study level of the water. Okay, the water level stands at the same level in each tube. Here you can see this is the level of water. Okay, this is the level of water. Thus, the liquid stands at the same vertical height in all the communicating tubes, whatever be the shapes. It does not depend on the shape of the container, and we know that liquid maintain its own level. Okay, liquid maintain its own level. This principle is used in the water supply system, a water supply tank or water reservoir, and are constructed at a taller place so that water rises in building without using water pump. Okay, simply liquid find its own level, liquid maintain its own level, and it does not depend on the shape of the container. Dear students, here now I am going to solve two numerical problems related to this chapter, and we have already derived the formula in the previous class, and here I just want to I am going to solve two numerical problems. A girl weighing is 40 kg, okay, and the surface area of the heel of her shoe is 200 cm square, okay, area square, and find the pressure exerted on the ground if she stands on her feet only. Okay, a girl weighing is 40 kg and surface area of heel of her shoe is 200 cm square, and find the pressure exerted on the ground if she stands on her feet only. Okay, now solutions. Here mass of girl m is equal to 40 kg and surface area of the heel of her shoe is 200 cm square. Okay, here surface area 200 cm square, and we have to convert cm square into meter square. So we can convert cm into meter by 10 to the power minus 2 multiply by and cm square, that's why into 10 to the power minus 4, or 200 divided by 100 into 100. Okay, so 2 into 10 to the power minus 2 surface area. Okay, and weight, that is F. Okay, it's it's equal to mg. It's equal to what? 40 into 10. You can also write here instead of 10, 9.8. Okay, so 400 Newton, and we know that pressure P is equal to F by A. Force here 400. Okay, by 2 into 10 to the power minus 2. Okay, here power minus 2, not only minus 2, and 2 into 10 to the power 4. Okay, is the answer. Hence the pressure exerted on the ground is 2 into 10 to the power 4 Pascal. Okay, likewise, another example. What is the pressure at 6 meter depth for a liquid that has density equal to 800 kilogram per meter cube? Okay, what is the pressure at 6 meter depth for a liquid that has density equal to 800 kilogram per meter cube? Solution: given density of liquid D is equal to 800 kilogram per meter cube, and depth S is equal to 6 meter, and we know that acceleration due to gravity 9.8, or we can use value 10 meter per second square. Okay, and we have a formula that is liquid pressure P is equal to SdG, which we have proved, and it's equal to 6 into height 6 meter into 800 into G10. Okay, it's equal to 6 into 8, 48,000. Okay, 48,000 Pascal. Okay, this is the answer, 48,000 Pascal. Dear students, now I am going to discuss about the another activity, that is experiment to prove atmospheric pressure. Dear students, we had already discussed about atmospheric pressure in the previous class. The pressure exerted by the atmosphere, that is the atmospheric pressure exerted by the air, and its value is 760 mm Hg at the surface of sea level, and it is measured by using barometer. Okay, it is measured by using barometer, which we have already discussed, and now I am going to discuss this atmospheric pressure with the help of a simple experiment. Okay, with the help of this simple experiment. First of all, take one empty tin can as shown in the figure. Here you can see this is the empty tin can. There is no lid in the tin can. Okay, it is open, and it is the tin can, and fill about half portion of tin can with water. Okay, about half portion of tin can is filled by water. Here you can see this is filled by water. Okay, and this, first of all, it is the empty tin can, and fill it with the water, and heat the can for some times. Okay, then heat the tin can for some times. Okay, until it boils. Okay, and after some times, the water present inside the tin can converts into vapor or steam. Okay, water converts into water vapor or the steam. Okay, and after sometimes hot steam comes out from the tin can. Okay, hot steam comes out from the tin can continuously due to heat. Okay, due to heat, the water present in the tin can converts into water vapor, and it comes out from the tin can. And after sometimes condense the tin can by filling cold water, and we also have to remove this source of heat from here. Okay, remove the source of heat which is present just below the tin can, which is situated just below the tin can, and then after Condense the tin can by filling cold water. Then after fill some cold water over here. Okay, and close the lid. Okay, then after what? Close the lid and let the tin can to cool down. Okay, condense the tin can by filling cold water. Okay, and close the lid and let the tin can to cool down. Let this tin can to cool down for sometimes. Okay, condense the tin can by filling cold water over the tin can. Okay, then close the lid and let the tin can to cool down for some times. Okay, and now the steam present in the tin can converts into water. Okay, the vapor present in the tin can converts into water, and there is creation of the vacuum inside the tin can. Okay, and at this condition, due to imbalance in the pressure inside the tin can, and the atmospheric pressure outside the tin can is crushed from all sides. Okay, tin can is crushed from all sides, and from this activity we can prove the atmosphere around the earth gives pressure, and the atmospheric pressure acts on all the sides of the body. Okay, atmospheric pressure acts on all sides of the body. एउटा सिम्पल एक्सपेरिमेन्ट छ। यो एक्सपेरिमेन्टमा सबैभन्दा पहिला एउटा टिन क्यान हामीले लिने, त्यसमा पानी राख्ने आधी जति। ओके, माथिपट्टिको टिन क्यानको यो लिड ओपन नै हुनुपर्छ। त्यसपछि तलबाट हल्का हिट दिने। हिट दिइसकेपछि यो टिन क्यानमा भएको यो जति पनि वाटरहरू छ त्यो वाटर भ्यापोरमा कन्भर्ट हुन्छ। ठीक छ, वाटर भ्यापोरमा कन्भर्ट भइसकेपछि यो बिस्तारै यो वाटर भ्यापोरहरू यो जुन यो ओपन पोर्सन छ यहाँबाट बाहिर निक्लिन्छ, र यो कन्टिन्युअस प्रोसेस चल्न थालिसकेपछि यो हिटको सोर्सलाई बन्द गरेर यो टिन क्यानको वरिपरिबाट हामीले यसरी चिसो पानी राखिदिने। ठीक छ, बाहिरपट्टिबाट चिसो पानी राखिदिने। चिसो पानी राखिदिइसकेपछि र त्यही बेलामा यहाँनिर जुन यो लिड पहिला थिएन, अब यसलाई लिडले के गर्ने, क्लोज गरिदिने। क्लोज गरिसकेपछि यो भित्र जुन वाटर भ्यापोर थियो त्यो वाटर भ्यापोर कन्भर्ट्स भएर फेरि वाटर नै बन्छ, र वाटर बनिसकेपछि यहाँभित्र के हुन्छ भन्दा एक किसिमको भ्याकुम क्रिएसन हुन्छ, इम्टी स्पेस क्रिएसन हुन्छ, जसको कारणले गर्दाखेरि र बाहिरपट्टिबाट जुन एटमोस्फेरिक प्रेसर छ त्यो एटमोस्फेरिक प्रेसरले गर्दाखेरि त्यो भ्याकुमलाई फिल गर्नको लागि त्यो टिन क्यान के हुन्छ भन्दा अलिकति त्यसको साइजमा सेपमा चेन्ज आउँछ, अलिकति के हुन्छ कचाकुचुक पर्छ, अलिकति खुम्चिन्छ त्यो। ओके, र यस एक्सपेरिमेन्टले हामी के प्रुभ गर्न सक्छौँ भने एटमोस्फियर exerts pressure. Okay, and from the all sides, सबै साइड्सहरुबाट यहाँ यो टिन क्यान अलिकति क्रस्ट भएको छ। Okay, from this activity we can prove atmosphere present around the earth gives pressure, and the atmospheric pressure acts on all the sides of the body. Okay, and this experiment is given in the government book. Okay, I think it is not given in your book, so you need to understand this experiment. Okay, this activity as it is given in the government book, and this activity proves that atmosphere gives pressure. And application of atmospheric pressure, uses of atmospheric pressure. Okay, due to presence of atmospheric pressure, different types of instruments like pen, syringe, air pump, water pump, etc. can be used. Okay, different types of instrument like pen, syringe, okay, which is used in the hospital, air pump, water pump. Okay, these all are used. Okay, these all appliances can work only due to atmospheric pressure, and we cannot use these all appliances without atmospheric pressure. Okay, you need to understand this application of atmospheric pressure. Okay. Okay, dear students, now write down some homework for you. First question, prove that liquid pressure P is equal to SdG. Liquid pressure P is equal to SdG. Another question, numerical. The length, breadth and height of water tank is 3 meter, 2 meter and 2 meter respectively. If half of it is filled with water, what pressure is exerted at its bottom? Okay, if the length, breadth and height of water tank are 3 meter, 2 meter and 2 meter respectively. If half of it is filled with water, what pressure is exerted at its bottom? Okay, another question. A drum is filled with a liquid. The height of the liquid in the drum is 2 meter and its pressure is 500 Newton per meter square. And what is the density of this liquid? Okay, what is the density of this liquid? Likewise, another question, give reasons. Studs are made on the boot of the football players, and the school bag is provided with wide straps. Okay, school bag is provided with wide straps. And another last question, the tip of the needle is made sharp. Okay, the tip of the needle is made sharp. Dear students, only this much for today. And in the next class, I will discuss about Pascal's law. Okay, and other law of flotation, Archimedes principle, hydraulic brake working mechanism, like this in the next class. And thank you for watching. See you tomorrow in the next class. Thank you for watching once again. Bye bye.